Quasars. Now we're getting into the big stuff. Picture this, billions of light years away from Earth. A light so intense it outshines entire galaxies. But what exactly is a quasar? A quasar is the ultra-luminous heart of a distant galaxy, powered by a supermassive black hole. This gigantic black hole pulls in everything around the gas, dust, stars. It's like a cosmic vacuum cleaner, but on an unimaginably massive scale. And when these materials get sucked toward the black hole, they form a fast-spinning disk called an accretion disk. This is where the magic happens. The gas in this disk heats up to incredibly high temperatures due to the extreme gravitational forces. This process releases an enormous amount of energy in the form of light, X-rays, and even radio waves. It's these emissions that make the quasar visible across the entire universe. Imagine a cosmic lighthouse shining through space, a point of light so powerful that we can see it billions of light years away, even though the galaxy itself might be nearly invisible. It's not just beautiful, it's a reminder of the sheer power and mystery that governs the universe. Quasars are some of the most extreme, energetic, and luminous objects we know of in the cosmos. But they're also remnants of a distant past. The light we see today has often traveled billions of years before reaching us. In fact, quasars give us a glimpse into the early days of the universe. They lie witnesses to what the cosmos was like in its turbulent youth. Alright, let's talk about one of the most dramatic events in the universe, supernova. Picture this, a star, many times more massive than our Sun, living out its life in relative peace, until it reaches the end. And when it does, it goes out in the most spectacular way imaginable. A supernova is the explosive death of a star. But not just any star, only the massive ones, those with at least 8 times the mass of the Sun, can create these cosmic fireworks. So, what happens exactly? Well, after millions of years of burning nuclear fuel in its core, the star eventually runs out of energy. And when that fuel is gone, the core collapses under its own gravity in a matter of seconds. This causes the outer layers of the star to be violently ejected into space, creating an explosion so bright it can outshine an entire galaxy, even if only for a short time. In those brief moments, a supernova releases more energy than our Sun will in its entire 10 billion year lifetime. Think about that for a second. It's a mind-boggling amount of energy. But supernovae aren't just cosmic fireworks for us to admire from a distance. They play a vital role in the universe. When a supernova explodes, it flings elements like carbon, oxygen, and air into space, elements that are crucial for life as we know it. In fact, the very atoms in your body, in the Earth, and in everything around you were forced in the heart of a star and scattered across the cosmos by supernovae billions of years ago. So, in a way, we are all meiosalis, the immensely select fusions. There are actually 2 main types of supernova. One is from massive stars collapsing, like I just described. The other happens in binary star systems, where a white dwarf, a small, dense star, pulls material from its companion star until it reaches a critical mass and triggers a runaway explosion. Different origins, but equally dramatic endings. And here's another amazing thing. Supernovae don't just end with an explosion. What's left behind can be a neutron star, one of the densest objects in the universe, or in some cases, the ultimate cosmic monster black hole. These remnants continue to fascinate astronomers, offering clues about the life and death of stars. Let's dive into one of the most beautiful and mesmerizing sights in the universe, nebula. These stunning clouds of gas and dust are like cosmic artworks, scattered across the galaxy, each with its own unique shape and story. So, what exactly is a nebula? In simple terms, a nebula is a giant cloud of dust and gas in space. But it's much more than that. Nebulae are the birthplaces of stars. Within these clouds, gravity slowly pulls dust together, forming dense regions that eventually ignite into new stars. It's like the universe nursery, where new life begins. There are different types of nebulae too. Some are emission nebulae, glowing brightly as the young stars inside heat up the gas around them. Others, called reflection nebulae, don't emit light themselves, but instead reflect the light of nearby stars, creating a soft, eerie glow. And then there are planetary nebulae. which aren't related to planets at all. Let's talk about one of the most fascinating and strange objects in the universe, pulsars. These cosmic lighthouses are the remnants of massive stars, left behind after a supernova explosion, and they're some of the most extreme objects out there. A pulsar is actually a type of neutron star, an incredibly dense, rapidly spinning star that emits beams of radiation from its poles. Now, here's the crazy part. These stars spin incredibly fast. Some of them rotate several times per second, others hundreds of times. As they spin, those beams of radiation sweep across space like the light from a lighthouse, and when the beam points toward Earth, we detect it as a pulse, hence the name pulsar. These pulses are so regular that they rival the precision of atomic clocks. In fact, for an hour after they were first discovered, scientists thought they might be signal from alien civilizations. Turns out, pulsars are just the universe shown off its own precision engineering. Pulsars are born from the death of massive stars. After a supernova explosion, the core that's left behind collapses into this tiny, super dense object. To give you an idea of how dense, a pulsar can pack more mass than the sun into a sphere only about 20 kilometers wide. That's like crying an entire star into a city. Pulsars are not just fascinating cosmic phenomena, they also help us understand extreme physics. Their immense gravity and rapid rotation push the boundaries of what we know about the universe. So, pulsars are not only incredible remnants of dead stars, but they're also niche so precise that keepers send they have cosmic signals that tell us about the mystery of space. Alright, let's journey into one of the most mysterious and mind-bending phenomena in the universe, black holes. These objects are the ultimate cosmic monsters, places where gravity is so intense that not even light can escape. A black hole forms when a massive star collapses under its own gravity at the end of its life. The core compresses into an incredibly dense point called a singularity, surrounded by an invisible boundary known as the event horizon. Once something crosses this event horizon, it's gone forever. Nothing can escape, not even light, which is why we call it a black hole. But black holes aren't just destructive voids. They play a crucial role in shaping galaxies and the universe itself. Some black holes are small, a few times the mass of our sun, but others, known as supermassive black holes, sit at the center of galaxies, including our own Milky Way, with masses millions, even billions of times greater than the sun. Despite their reputation, black holes aren't cosmic vacuum cleaners, sucking up everything in sight. You actually have to get pretty close to one to be pulled in. But once you're in, there's no coming back. In many ways, black holes are like window into the unknown. Let's talk about asteroids, those rocky remnants left over from the early days of the solar system. These space rocks, ranging from just a few meters to hundreds of kilometers wide, silently orbit the sun. But what happens when they collide? Asteroid impacts are like cosmic car crashes. Where two asteroids collide, the force can be absolutely massive. Depending on their size and speed, the collision can either shatter them into countless smaller fragments or, in some cases, merge them together, forming a larger asteroid. These impacts are a key part of how planets and moons formed billions of years ago. But asteroid collisions don't just shape the past, they can affect the future. If an asteroid's path is altered by a collision, it could be sent on a new trajectory, potentially towards Earth. While most asteroids burn out in the atmosphere as meteors, the larger ones can cause significant damage. The impact of asteroids is part of the constant dance of the solar system, with rocks crashing, urging, and sometimes causing massive destruction. It's a chaotic and dangerous process, but it's also part of what built our world, and so, the cosmos continues its dance full of creation, destruction, and endless wonder.